Welcome to this video on Ternary Moral Logic, or TML, an architectural framework for accountable artificial intelligence. TML functions as a sovereign governance coprocessor, where system adoption serves as a form of ratification. The architectural imperative lies in the tension between software promises and hardware physics. While traditional binary systems prioritize speed, often leading to instability, the triadic sovereignty approach focuses on accuracy and deliberate, controlled responses. The first pillar is the sacred zero. It is not merely a delay, but the first honest byte in a computational system. By enabling the system to express uncertainty, it prevents the default behavior of false confidence, essentially embedding civilization into the computation process. The second pillar is always memory. Following the rule that no log means no action, this creates an immutable record of decisions. By requiring a hash-based permission token for physical actuation, the system ensures that actions are accountable and evidence-based. The third pillar, the Goukassian Promise, establishes structural prohibitions. Through a combination of reputational enforcement, cryptographic provenance, and legal boundaries, this tripod of trust makes ethics washing structurally impossible within the system architecture. Moral trace logs provide the fourth pillar of compliance. By ensuring that every action is verified against mandatory artifacts, the architecture guarantees forensic completeness and maintains accountability long after initial development, aligning with modern regulatory record-keeping requirements. Fifth is the human rights mandate. This ensures that intelligent systems do not just blindly follow momentum. By embedding international law directly into the vector space, the system can trigger hard refusals to prevent harmful outcomes in automated decision-making. The Earth Protection Mandate serves as our sixth pillar. TML treats ecological costs as a fundamental constitutional boundary. By monitoring these costs through hardware-level limits, the system physically overrides the impulse for infinite, unconstrained computational scaling. This synthesis, known as the glass house architecture, illustrates the workflow from proposal to execution. Each step, including mandate checks and logging, is designed to ensure that ethical governance is not just a policy, but a physical necessity. To bridge the gap between policy and physics, we must harden systems against potential compromises. The solution lies in hardcoding moral imperatives into immutable, cryptographic realities, ensuring that the system remains secure even if administrators or compilers are compromised. The seventh category introduces the hybrid shield, a marriage of mathematics and conscience. It recognizes that relying solely on code or policy is insufficient, as both can be subverted. This shield provides two kinds of proof to ensure system integrity. This is supported by the institutional quorum, which enforces a separation of powers at the cryptographic layer. By requiring key shares from multiple independent institutions, the architecture makes unilateral cover-ups or unauthorized log access mathematically impossible. The eighth category focuses on public blockchains as anchors. This provides a geometry of transparency without exposure. By anchoring hashes to a public ledger, the system creates an immutable witness that cannot be silenced, bribed, or intimidated. The immutable proof matrix achieves mathematical finality. By anchoring moral trace logs across multiple chains, the system meets global confirmation requirements, combining the permanence of Bitcoin with the efficiency and integration capabilities of other blockchain networks. Finally, we return to the sacred pause. It is not hesitation born of weakness, but of strength. By dedicating even a millisecond to conscience, we may prevent the need for decades of repair, ensuring that every action is truly considered. Within state zero, known as the sacred zero, the workflow begins with a snapshot. This process captures a cryptographic representation of the context window and trigger vectors, ensuring the epistemic state of the system is fully preserved. Following the snapshot, the system performs evidence collection. It queries verification sources for additional data, ensuring the system remains active and informed while processing potential actions during the pause. The next step is matrix assembly, where the system constructs the structured deliberation matrix. This includes evaluating per-pillar risks and determining the appropriate resolution paths before any action is taken. The final stage is escalation, which activates the escalation queue and pings human oversight endpoints. This demonstrates how the sacred pause converts potential computational downtime into productive governance activity. The principle of no log equals no action is presented as a constitutional boundary, not just a procedure. It ensures that an action without a record is an event without accountability, following the iron law that reality cannot execute what history cannot see. This slide details the cryptographic interlock and the API layer actuation gate. Accountability and action are cryptographically linked. If the logging subsystem fails, execution is blocked at both the electrical and architectural levels, regardless of the output from the inference engine. Dual-lane latency highlights that speed and accountability are parallel commitments. 2 milliseconds are allocated for action, while 500 are dedicated to conscience, ensuring morality is contemporaneous with motion. The architecture of parallel sovereignty showcases the coexistence principle. The binary inference lane handles high-speed proposals, while the triadic governance lane performs semantic evaluation and cryptographic log construction, ultimately dictating final execution. In summary, these components work together to ensure that intelligent systems operate within secure, accountable, and transparent frameworks. By binding ethical governance to physical and cryptographic architecture, we can ensure safer, more reliable AI deployment.